welcome to Monograph Matters. I'm talking today with Jamie Carroll, David Yeager, and Robert Crosnoe, authors of the SRCD Monograph on Mindset by Context, Schools, Classrooms, and Unequal Translation of Expectations into Math Achievement. This discussion focuses on how can course taking serve as a window into math, STEM, and broadening participation? How can course taking serve as a window into math, STEM, and broadening participation? In what context is course taking particularly critical for understanding math, STEM fields, and participation in educational opportunities?
Math is an interesting subject, and it's one that sociologists of education have always been fascinated in because it tells us so much, not just about the student, but about the system, and especially inequality in the system. And there's really four characteristics of math coursework that are important here. The first is that it's very hierarchical. So math courses are arranged from, in a series from low challenge to high challenge, which often doubles as low status to high status. It's also cumulative, which means that each class builds on the one before it in this very cumulative fashion. And that means, that everything is predicated on what happened before that. And students' pathways through the math curriculum also become very self-propagating, and it's very hard once they're underway to reverse them or to change course or to go back, right? Or to do something different. Math coursework is also very consequential. It is one of how far students go in the high school math curriculum is one of the best predictors we have that we know about of graduating from high school, matriculating in college, graduating college, not just majoring in STEM, just college in general. And lastly, it's highly discretionary, or at least it's more highly discretionary than many other subject matters. There's discretion in whether to take math at all, especially as you get towards the end of high school. There's also discretion in what math classes to take if you are going to take math. And that can be discretion on the part of the student, right? The choices that they make, which really emphasize the importance of things like personality and confidence and, and all of that. It could reflect discretion on the part of parents. Are parents pushing kids in one direction or not? Are they mustering all the advantages that they have to push their kid ahead or not? And then, of course, there's also the discretion of the school and the teachers, the gatekeepers, right? Do they see something in the kid that influences their decision to encourage some enrollment or not? And is that just based on their perceptions or something real? This is where biases and stereotypes can come into play. So all four of these things converge to make math coursework a real window into inequality and the place where inequality takes hold. It shows you whether certain student groups are stratified, opportunities to learn that are available to them, and where they are going. And for those reasons, what happens when kids are growing up that influences that, if they experience disadvantages growing up that affect what they're doing in high school, and what they're doing in high school affects what they're going to be doing through adulthood. That is precisely how disadvantages in one generation become disadvantages in another. That is the intergenerational cycle of inequality, and math coursework is a window into that. So you wouldn't think just something simple like, are you in algebra, and when are you in algebra, is telling us all that much beyond things like achievement and test scores, but it is. It's telling us something very important about the state of the educational system in the United States and where any individual kid and any individual group of children or adolescents is positioned in that system.
Importance of math, given that it's so hierarchical, we can really track over decades how inequality and access to higher versus lower level of math courses impacts people's longevity and their lives well after high school. In some work that I've done previously with the High School and Beyond data set, we've found that students who were in high school in 1980 who took more advanced math courses in midlife are in better health, make more money, are in better more likely to be in better STEM jobs, have lower mortality risks, and are more likely to vote. And so this is regardless of their grades and their educational attainment. So there's something about adolescents being in more advantaged math courses, and especially knowing that these math courses have better learning opportunities, more opportunities to critically think and problem solve and learn abstract thinking. That is not only important for students' educational opportunities, but also for their life well into adulthood.
Read more about this topic in the monograph issue, Mindset by Context, Schools, Classrooms, and the Unequal Translation of Expectations into Math Achievement by Carroll, Yeager, Temple et al. If you like this video, consider watching our Monograph Matters playlist. For additional resources related to these and other issues of the monographs of the Society for Research in Child Development, please visit monographmatters.srcd.org.